Throughout the history of railroad, the most difficult challenge has been stopping the train, not getting it started. In the olden days, when steam locomotives pulled trains, they had men that actually crawled across the tops of the cars and applied brakes by hand as a train started going down a hill. Sometimes the train would run away and the locomotive would be unable to stop the train, which would result in a huge crash at the bottom of the hill. Refinements to air brakes meant an improvement, but even then, each car had to have retainers set before a train would start down a long hill, which would create heat as the brake shoes ground against steel wheels. In some cases, the heat would actually catch the trucks on fire and the wheels on fire. A great advance came with the coming of the diesel. One of the very first diesels for the Santa Fe Railway had an innovative approach that resulted in dynamic braking being applied to many diesel locomotives. So today we're going to discuss dynamic brakes. Dynamic brakes operate whenever the locomotive is set up for descending a hill and the dynamic brakes kick in. Instead of electrical power powering the traction motors that cause the train to roll, now the traction motors are turning the motors into generators that generate electricity. This is very hot work whenever the motors are turned to generators, so the traction motor blowers have to blow a lot of cool air down on the motors to keep them from overheating. The current, instead of coming into the traction motors, is now leaving the traction motors. It starts going up. Where the destination of the current is to a dynamic brake resistor grid where the current is forced through a bank of large resistors. Resistors force the current to be reduced and the voltage to be reduced. This creates electromagnetic force back pressure, which is basically forcing current back against itself, which slows the traction motors, which are now being used as brakes, slows them down, and they slow the wheels of the locomotive down. So now the locomotive is providing braking without brake shoes being applied to the wheels. The dynamic brake resistor grid overheats, so it requires a cooling fan to turn a huge fan blade and blow cool air through the dynamic brake resistor grid. The remaining heat goes out into the atmosphere, and this is what slows the train down when it's descending a long grade. Dynamic brakes reduce wheel wear, eliminate brake shoe wear, and makes it a lot safer for a train to descend a grade.